Today we're going to talk about scientific notation. We'll go over the format and some examples. So we use scientific notation to show really large numbers or really small numbers. So the format is m times 10 to the n. M equals a number greater than or equal to 1. But less than 10. N is a whole number. If it's positive, then you have a large number. If it's negative, you have a small number. So let's go over two examples. If I have 65,000 kilometers and I want to write that in scientific notation. So I want a number greater than or equal to 1 but less than 10. So there's not a decimal point here, but I'm going to start at the end and move to the left 1, 2, 3, 4 places. I get 6.5, that's my m, times 10 to the fourth. You have to include kilometers. Now if you notice, I didn't write the zeros in my scientific notation. Here in the standard notation, these zeros are not significant. There's no decimal point. They're trailing without a decimal point. If I write them here in the scientific notation, because we have a decimal place here, they would become significant. So we would go from 2 sig figs to more than 2 if I wrote them here. You want to make sure your number of sig figs does not change when you're going from standard form to scientific notation. If I have a small number, 0.00012 millimeters, I'm going to move my decimal point to the right. 1, 2, 3, 4. So I'm going to get 1.2 times 10 to the negative fourth millimeters. These zeros are leading. They are not written. Leading zeros are never significant. So we have both of these have the m where it's greater than 1 but less than 10, greater than or equal to 1 but less than 10, and then we have our whole numbers for our n numbers.